So, good morning, everyone. Hope you are doing well. So now we are in the fourth week of our data analytics lesson. So we identified data analytics as the process of data analysis as the process of inspecting, cleaning, transforming, and modeling data to discover useful information. Right? Then that information help us to make better decisions. That information helps us to make better decisions. So that's why we call data is the most important asset in the modern digital world. Right? So, but data on its own are just raw facts that does not have a meaning. Right? So after analyzing and after processing or after giving them a context, they become valuable. Right? As example, I'm giving you a number. Let's say 85. Right? What can you say about this? It's just a number. It's just a fact. It's just a data. Right? So that does not tell us anything. Right? So what if after analyzing we can I'm giving this a context, right? Let's say this is a mark of a student for IT. This 85 is a mark of a student uh, for the IT subject, right? Then based on this information, we can make decisions. Or we can say he will get an A pass for this subject, right? So that is data and that is data analytics, how data become information. We discuss about data life cycle, right? So it's a structured iterative process. It's an structured iterative process that guides us to handle data. Data lifecycle is a structured iterative process that guides us to handle data. So it helps us in transforming data into meaningful insights, right? So it has 6 phases as discovery, preparation, model planning, model building, communication results, and operationalize. Right? So discovery is the phase where we focus on understanding the business problem and defining the business objectives. Then data preparation is the plan phase where the relevant data is collected and we clean them and organize them in a manner that we can ensure the data quality and the data consistency. Then we have the model planning, right? So here we use the appropriate statistical techniques and tools uh, based on our objective, right? Then we have the model building phase, and after that we get the results. So communication results is the phase where we summarize and present those findings, right? Then operation, these findings get implemented, right? So the businesses implement these findings, right? And right, so that's data life cycle. And there are three major types of data analytics. You can remember descriptive, predictive, and prescriptive, right? Right. In descriptive analytics, we focused on past data to understand what happened in the past. Then predictive means, right, we analyze trends and data to predict the likelihood of a future outcome, right? We analyze trends and data to predict the likelihood of a future outcome. Then prescriptive means in prescriptive analysis, we go beyond from prediction, right? We try to predict the likelihood of an event, and uh, the, the the steps we can take. We give the steps we can take to get benefits from those opportunities, or reduce the if it is a threat, the steps you should take to reduce the threat. So that's descriptive, predictive, and prescriptive analytics. So for all these analytics, one of the key skills you should have is the knowledge about statistics. Statistics, right? Right. So there were two types of statistics: descriptive, 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 and inferential statistics. Using descriptive statistics, what we did was summarize and interpret data. Summarize and interpret data. So there we had two things: measures of central tendency, and measures of variability. Measures of variability or the dispersion, right? In central tendency, we had the mean, median, and mode. In measures of variability, we had the range, then standard deviation, and the variance, right? Then in the inferential statistics, was about making predictions. The sample, we had a population. From that population, we derived a sample. Using that sample, we tried to make predictions about the population. Then we discuss about the probability distribution. Probability distributions. Probability distributions. What do we mean by probability? Probability means a likelihood of an event happen, right? Likelihood of an event happening, right? So it's a number between 0 and 1, right? 0 and 1, right? So probability distribution simply shows all the possible outcomes of an experiment and their possibilities, right? In a normal distribution, data is balanced, right? So most of the data points are uh, gathered around the mean, median, and mode, right? So then it can be negatively skewed and positively skewed, right? So negatively skewed and positively skewed. So why finding this probability distribution was important is because most of the statistical techniques assume that our data is normally distributed. So after uh, after proving that the data is normally distributed only, we can do the statistical techniques like t-tests. Right? Then we had sampling techniques. Sampling techniques was because in inferential statistics we discussed, we are trying to make a prediction about the population based on a sample, right? So we have to take a sample uh, that sufficiently represent the entire population, right? We have to take a sample that sufficiently represent the entire population. So that's why we use sampling techniques. So for the sampling techniques, we use simple random sampling, systematic sampling, stratified sampling, and cluster sampling. So these are probability. So generally we can divide sampling techniques into two: probability sampling and non-probability sampling. So these are probability sampling. So probability sampling means every element in the population has some sort of probability of getting selected, right? So in simple random sampling, we just picked elements from uh, the population. So there is an equal chance of an element to get selected, right? So then we had the stratified sampling. So stratified sampling, what we did? So based on a feature, we divide based on the characteristic or the feature, we divide our population into uh, groups, right? So from each group, then we use random sampling to collect elements. So thereby we can uh, ensure that uh, all the elements that with uh, different characteristics get selected. Then in a systematic sampling, we find an uh, starting element and we select every nth element, right? Then pick in cluster sample, we divide the population based on their characteristics into a cluster and the entire cluster is selected, right? So those are the uh, probability sampling techniques, right? So then we have the non-probability sampling techniques as convenience sampling, snowball sampling, like what. So why we go from probability sampling to non-probability sampling is because sometimes when you are doing research or when you are collecting data, so because of the time constraints and the budget or the cost, we can rather than going for probability sampling, we go for a non-probability sampling. So convenience sampling is basically based on the researcher's convenience, we select a sample. So there we can't ensure that our sample will sufficiently represent the population. Analytic results may not uh, statistically valid. Then determining sample size is also important because it's also because our sample need to sufficiently represent the population. So whenever the sample size get increase, the let's say the sample mean will get closer to the actual population mean, right? So that's what we are trying to do, right? So we are trying to calculate a sample statistical value. Then based on that, we try to predict the actual or the population that statistical value, right? So from the sample mean, we try to predict as an example, from sample mean, we try to predict the population mean, right? So when the sample size get increases, or that statistical value get closer to the population's statistical value. So to do that, we have sampling techniques like Cohen's statistical table, right? Formulas like Slovin's formula. So here n is the sample size, capital N is the population size, and E is the margin for error, right? Right. So after collecting the data from the sample, we have the data pre-processing. So it's a four-step process. First thing is data cleaning, then data integration, data transformation, and uh, data reduction, right? So why we do this? To ensure data quality. So we do data pre-processing to ensure data quality. We do data pre-processing to ensure data quality. Ensure data quality, right? So data quality means data need to be accurate, complete, consistent, and timely and accessible. Accurate, consistent, complete, timely, and accessible, right? So to ensure the data quality, we do the data processing on the data we collected from the sample, right? So data cleaning is the phase where we remove uh, inconsistencies, errors, and duplicates to ensure that it's ready for the data analysis. So there we have handling missing data, handling noisy data, likewise. So after that, after the data pre-processing, after doing the data pre-processing, we can move to the data analysis, right? Predictive analysis. Predictive analysis is to determine the possible outcome, uh, of an event or the likelihood of a situation occurring. So there we use techniques like regression, time series analysis, and data mining, right? So then we discuss about the coefficient correlation, variable, random variable, right? Numeric value that represents outcome of a random process or an experiment. So as an example, think about you are rolling a die, right? So the outputs you can get are 1, 2, 3, 4, 5, 6. So that we call a random variable, right? An outcome of a random process, right? So, and we discussed, we can consider in our data set, we have, let's say in Excel sheet, we have attributes, right? Like age, uh, marks, let's say marks. Likewise, we have attributes. So we can consider this as a random variable because for each element, this value will belong to a one element, right? One row. Each row represent a different element, or the each row represent a one item. So these columns can be considered as random variables. Each column in your data set represent a random variable, right? Because the values are vary from one. Let's say this is a data set about students. So these values are different from one student to another. So this value will be different from this value. So therefore we can consider it as a random variable, right? So when we are rolling a die with the output, we can get a 1, 2, 3, 4, 5, 6, right? So different outcomes, right? So that outcome we call as a random variable. So here also the same, right? Each element has different values. So therefore we can consider it as random variables. So why identifying these are as random variables is important. So then we can discuss about coefficient correlation. It's about identify the relationships between these variables, identify the strengths and the strength of the relationship between these variables. So there we had perfectly negative relationships and perfectly positive relationships, right? Perfectly negative and perfectly positive relationships. So here under correlation coefficient, we measure two things: how strong the correlation is and how strong the correlation is and which direction the correlation goes. Which direction the correlation goes. Right. So here -1 indicates a perfectly negative linear relationship. Perfectly negative relationship. That means whenever the x get increased, the y's value get decreases. And the perfectly positive relationship means whenever the x increases, y get increases. So if the correlation coefficient is 0, that means there is no relationship. So then we discuss that what we try to do is right. So after what we did was we take the data from a sample and evaluate the sample, right? So we calculate the correlation of coefficient of a sample variable, right? A variable in our sample, right? Let's say between two variables, we calculate the correlation coefficient of two variables. What was the equation? The equation was R equals sigma x xi minus x bar. Xi means a data point, right, in the x-axis, x bar is the average. Then yi minus y bar divided by sigma xi minus x bar square by I minus y bar square root of this. So this was the equation to calculate correlation coefficient between two variables. So how can we ensure that this this relationship exists in the population as well? So we want to know if there is a correlation in the population as well. So therefore we did hypothesis testing, right? Hypothesis testing is closely related with this predictive analytics, right? So in hypothesis and test, what we did was uh, we had a null hypothesis and a alternative hypothesis. Null hypothesis and a alternative hypothesis. So so we start by assuming null hypothesis H0 means there is no correlation in the population. We assume there is no correlation in the population. And then the alternative hypothesis is there is a correlation in the population, right? So then how we analyze it? So we collect the data, then we clean them, and we do a statistical analysis to find the p-value, probability value, p-value. So we can find the p-value using a test like t-test, statistical test like t-test. But to do the test, our objective is to find the p-value, right? But to do this statistical test, we need to first prove that our data set is following a normal distribution, normal probability distribution. So first we have to do a normality check. After doing the normality check, we can do the statistical test to find the p-value, right? Find the p-value. Then we check whether our p-value is larger than or p-value is larger than or lower than the significant level. So significant level. So which we can, in most cases, is 0.05. So if it is lower than the significant value, we can reject the null hypothesis. So that means we are accepting the alternative hypothesis. That means we can show there is a correlation in the population as well, right? So that you can understand the flow, right? So in descriptive analytics, what we did, we try to interpret a data set, right? We try to interpret. Then we have the predictive analytics. Predictive analytics, what we tried to do was make a prediction, right? So there we had the sum, the population. So we can't analyze the entire population, right? So as an example, I took, let's say Amazon want to analyze their customer satisfaction for the past year. for the past year. So can they collect data from the entire population? Then the population will be their customers, right? So Amazon will have millions of customers, right? So it's impractical to collect data uh, from the everyone in the population. So therefore, they should collect uh, they should collect collect data from a sample, right? So there we have the sampling techniques, right? Sampling techniques to ensure that sample is sufficiently representing the population, right? So then we do the statistical analysis, statistical and mathematical and these data analysis to the data we collect from the sample. So before doing the analysis, we need to clean and pre-process the data, right? After pre-processing, we can ensure the data have the necessary quality to do the analysis. That means accurate, consistent, complete, reliable, and timely. Then after doing the data pre-processing, we can move to data analysis. Let's say to do a statistical test by t-test, we have to first ensure that our data is in a normal distribution, right? So we have the normality checks as well. Then we have so then we did the statistical analysis on the sample. So how can we ensure that this is valid for the population as well? So yeah, we use like hypothesis testing. So that's the flow, I think you can understand. So then today what I will do is I will try to create a project with you, a real world data analytics project, analysis project. Then you can understand how we are implementing these theories into a practical scenario, right? Okay, so to do data analytics, we can use for these projects, we can use platforms like Google Colab, Jupyter, uh, Jupyter Notebook, or we can use VS Code as well. So here today I'm going to use this Jupyter Notebook. Today I'm going to use Jupyter Notebook, and you can do the same thing using Google Colab. So this is easy actually. So you don't need to set up your environment. So to do, I will do it with Jupyter Notebook. Then you can do your project using Google Colab, right? So what I want to do is, in first week, you can remember we discussed about kaggle.com, right? So there we can get freely available data sets. So what I try to do is I will try to download the data set about COVID-19 and try to analyze this data set. So analyzing and find out what are the insights we can get from this data, right? So I'm using Jupyter and Python then as the programming language. I will install Python. First I will install Python, then install Jupyter Notebook, then download a dataset, download dataset, then we'll analyze. Okay. So this is what we are going to do, right? Okay. So So open your browser and search download Python. Download Python. And from the first search result, you can go to the first search result. So then you will be directed to python.org website. Then you can download the latest version of Python. Download the latest version of Python. Right? After downloading, you can do the installation like a normal software, right? So click on the downloaded setup file and install it. Install it. Okay. So setup was successfully installed. So you can close the setup. So now we need to ensure that Python installed successfully. So to do that, open the command prompt, search cmd, and you will see the command prompt, right click and run as administrator. පුතේ ඔයාලට මගේ ස්ක්‍රීන් එක පේනව නේද? බිනාසි පුතේ ඔයාලට මගේ ස්ක්‍රීන් එක පේනව නේද?
Yes, sir. I can see.
So okay. You can see the command prompt, right? පුතේ command prompt එක නේද පේන්නේ?
Yeah. Administrative.
Okay. Okay, පුතේ. Then we need to then type the command Python version. Python version. Okay. So you will get an error. You will also get an error like this. Python was not found. Run without arguments to install from Microsoft Store. Right? So the computer is unable to identify Python even though it's installed. So we need to add the installed location to the environment variables. So that will solve this problem, right? So again, in the search bar, select type Python, then you will see this .exe file, right click and open the file location. Then here you will also you will see a shortcut for the .exe file, right? So right click and open the file location, right? So then we need to enter this path. So we need to enter this path, this file path to the system variables and to the environmental variables. So copy this path. I will copy it to a notepad. Okay. Then go to this script file as well. and I need the path for the pip files as well. So copy this as well. Copy this and let's go to the environment variables, right? Search environment variables, open the environment variables, then here go to environment variables and under user variables, select path, edit, and add the new path, right? So copy this path and add it here, right? And the path for the pip files as well. Okay. Click OK and add this path to the system variables as well. Go to path, edit, and new, copy the path here as well. Then click OK. Then you can close this and open a terminal again. Right click, run as administrator. Now let's check Python is successfully installed. So type Python version. Right. Now the computer recognizes the Python version, right? So Python 3.13.13.3 is installed. Then pip version 25.0.1 is installed, right? Right. Then we have to install the Jupyter Notebook, right? So here this pip is the package manager, right? Python package installer. Python package installer is the pip stand for Python package installer, right? So using this, we can install modules and libraries of Python, right? Okay, so using pip, now I'm going to install Jupyter Notebook, right? So here pip install Jupyter, Uh, I think so. It's asking me to update the pip version. Okay, so a new release of pip is available 20.25.1.1. To update, run this command. So I will copy this command and run it. Python.exe -n pip install -upgrade pip. So the version will get downloaded and will get installed. It's successfully installed. Now let's install Jupyter. So pip install Jupyter. Then the Jupyter will get downloaded and installed. Okay, so we have successfully installed Jupyter Notebook, right? Then, yeah, okay, you understood what we did, right? So what we did was we are now trying to uh, uh, create a new project. So first we need to install Python, right? Install Python in your computer. Then install the Python package manager as well, pig, right? So then we learn that there are code editors like Google Colab, Google Colab, and Jupyter Notebook, where we can do the data analysis project, right? So here we will use Jupyter Notebook, right? So using Python package manager installer, I have installed Jupyter Notebook, Jupyter in my computer, right? So the command is pip install Jupyter, right? Then what I try to do is using this Jupyter, now I will create a Jupyter project. Project. Then after creating this project, my objective is to download the data set, and analyze it, analyze. So I will download the data set from let's download it from Kaggle, right? So we discussed that in the first week as well, when we are doing a simple data analysis using Excel, right? Hope you can remember that, right? Here also I will download the data set from Kaggle and analyze it, right? So here, now we have successfully installed Jupyter, right? Now let's create a project using this installed Jupyter notebook, right? Okay, so Jupyter is our code editor, right? Okay, right. So you can check the Jupyter installation. So type Jupyter version. Then if the Jupyter successfully installed, you can see the installed version. So right. So now I want to create a new project. So create a new folder, and open the folder using command prompt, right? So here in the file path, type cmd and the command prompt will appear for this directory, right? So I have created a new new folder in this location, advanced data analytics week 4. So here I have created a new folder. Now I have opened terminal for this, I have opened terminal and moved to this directory, right? So you can do it by uh, uh, typing cmd in this file path, right? Right. Right. Then type Jupyter note notebook. The notebook. This will open Jupyter Notebook in your browser. So it will start in as a web application, right, in the localhost port 8888, right. Then here we want to create a new project, right? So new Python project, Python 3 project. Okay. Then open the project. Okay. Then let's rename it. Let's name it as data analytics project. You can see the project. What is the extension? Extension is IPYNB. IPYNB. Right? So for a Jupyter project, Jupyter file, the extension is IPYNB. Right? So for a Python file, what is the extension? .py. For a C#, what? .cs, right? So from the extension, the computer knows, okay, this is a Python file, this is a C# file, this is a text file, right? Then he is able to, like, let's say it's a text file, so he will open the file in using a text edit. So if it is a MP4 file, he will open it in the using the media player, right? So from the extension, the file extension is by the computer knows what type of file is this. So here for the Jupyter files, the extension is IPYNB. Okay, if it is Python, right? IPYNB. Okay, so here you can simply type Python commands, right? Python commands. So I will print hello world first, right, as our first uh, command. So you can type print hello world. Hello world, right? Okay, Fatima, let's try to do this with Google Colab as well, right? Which is a similar environment, but much easier, right? Fatima, go to open your browser and type Google Colab. So we'll try to do the same thing using Google Colab as well. So go to Google browser pane on it. You can see the browser, right?
Yeah.
Yeah. Search Google Colab. Colab is a what? Google Colab is a hosted Jupyter Notebook service that requires no setup to use and provide free access to computing resources. So to use Google Colab, but we don't need to that requires no setup to use and provide free access. So that setup part we don't need to do when we are using Google Colab, right? So I can simply open Google Colab. Then I can open a new workbook. Then I can simply write the code here, right? I can, right? So it gives me the output as hello world. So now let's go to kaggle.com and download a data set. So let's download a COVID-19 data set. Okay. So I will download this data set. So you can sign after signing up, then download the Excel sheet. So let's download dataset as a zip file. Then extract the downloaded dataset. Okay, this is the dataset. Comes as a Microsoft Excel file. So let's first open and see what can how the dataset looks like. So I will open this. So this is the dataset, right? So it has ID, the province, and the country, province, country, and the dates and the confirmed. Confirmed means how many persons are confirmed as they have COVID-19. That means from that confirmed personas, how many of them are died. So the, the, in the Guam province, for in 2020, 2022, January 22, they identified 0 patients and there were 0 deaths. Right? So this data set, you can see the country is United States, and we have the provinces and how many for the particular day, how many people could confirm as they have in that day, right? So there are like around 10,000 or 10,000 data in this data set, right? So can we analyze and can we make decisions from this Excel sheet just looking at this data? So to analyze, we use Python. We use data analytics tools. Okay, that's why we need to be familiar with Python, Jupyter. Also, we can use R programming language, and we have tools like SPSS. Then after analyzing, we use data visualization. Data visualization is show the results. Right? So we will see how we can analyze and do the data visualization for this particular data set. Okay, so the first thing, okay, so now we have a data set which we need to analyze, right? So we are going to use Python for this analyzing. All right, right? Then here we have a library called Pandas. Pandas. So, Benazir, can you tell me what is a library? In programming, what is a library? Right? Right.
I don't know, sir.
Okay, Bhuti. Library is something like this. So when we program, we are using libraries. Like so we can't build everything from the scratch. Okay, Bhuti. So imagine, so as an example, when we are developing a web application, for the styling, we use a library as Bootstrap, a simple example, right? Because somebody else has written all the code with animations, with like fonts and everything. Somebody else has written that code. So rather than reinventing the wheel means rather than developing things from the scratch, we just use that library to style our website. So here the same, right? So we can't from the scratch write the code to analyze this data, right? Somebody else has done it. So we call it as a library, right? So we can install that library in our, we can use that library, that piece of code in our program, and we can use that to analyze data. Okay. So somebody else has written, so we are just using it. That's the idea, a library. We are not building things from the scratch. We are using a library. Okay. So let's see what this pandas is. So one of the most important skill you need to have is reading the documentations. As a software developer or IT graduate, you need to have the skill, the ability to read documentation. So we know, okay, we have to use a library as pandas. So let's see what the pandas is. Okay, go to your browser. Here, pandas. So what is pandas? Pandas is a fast, powerful, flexible, and easy. Pandas is fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of the Python programming language. So what is Pandas? A fast, powerful, flexible, and easy to use open source data analysis and manipulation tool built on top of Python programming language. So I want to know how can I use this library. So I will go here and read getting started. Okay. So prefer pip. I have already installed pip. So pandas can be installed via pip using this command pip install pandas. Then here we have getting started tutorials. So if you want, I want to start using pandas. First, I need, after installing, I have to import pandas as PD. Then uh, right? So what I will try to do today is, okay, what I will try to do today is, okay, I will this, install this pandas library using pip package installer. Then I will use it in my project, right? In my project, using this library, I will analyze the data set I downloaded, COVID-19 data set. Okay. Using this library, I will analyze this data set using pandas. Okay. So first thing is what then? Installing pandas in the system. Understood? Right. So I will open the command prompt. Type the command pip install pandas. Okay. Then the library will install. Okay. Then after installing, I will import pandas library on top. Import pandas as PD. Right? Then this pandas as PD. Right? PD is the object. Right? PD is the object. Then I can read the Excel sheet using pandas, right? So to do that, we have a method as panda read CSV, read underscore CSV, data CSV file in a data frame, right? Then type data, shift enter. So then you can see the Excel sheet in a Excel sheet in the Jupyter Notebook. You can do the same thing in the Google Colab as well, right? So this we call as a data frame. So you can think about it as an Excel sheet, right? Which we have the rows and columns, right? Now we will explore this data set. Let's see what are the first 5 elements in this data set. So we can use data.head method. Data.head method. So which will give us the first 5 elements. So, and the indexing you can see starting from 0, 0, 1, 2, 3, 4, right? 0, 1, 2, 3, 4. These are the first 5 elements. Okay. So then we can check what are the columns, what are the attributes in this data set. So you can see data.columns, data.columns. So which will give us the all the columns, all the attributes, right? Right. So these are our attributes, right? Then let's do a simple analysis. So first, let's see what are the we saw what are the first 5 elements. So let's see what are the last 5 elements. So you can use the command data.tail. So which will return us the last 5 elements. Data.describe will return us So we will use data.describe command. Data.describe will return us the descriptive statistics, right? So count, mean, standard deviation, mean, 25%, 50 or 75% max, like that. So you can see in our data set, this UID, code, lateral law, those are not, those are data that we don't necessarily need for this analysis, right? We are trying to analyze the dates and confirm dates by the country and the province. So there are unnecessary data. So we need to remove those things, and we need to remove duplicates, and we need to handle null values. First, let's check let's remove the unnecessary values. That means lat long, FIPS, code, UID, those things we do not want. So from these all the attributes, let's remove the unnecessary things. So let's check what are our attributes, data.columns. So we have UID, ISO2, ISO3, code 3, FIPS, admin2, province state, country region, lat long, combined key, date, confirm dates. Okay. So I will drop these columns. So I create an array. Columns to drop are UID, ISO2, ISO3, code 3, FIPS, admin2, province state, lat long, combined key. So these things I will drop. Right? So here I am doing the data cleaning, right? You can understand. I'm removing unnecessary data. So data drop these columns. So the command is data equals data.drop. I'm using drop method. Drop these columns to drop, right? So those columns will get dropped. Now let's see what we have. So again type data dot columns. Okay, now we have country, date, confirmed dates, right? So those things now we have, right? Okay, now let's see the first 5 values. So now we have only these 3: country, region, date, confirmed, and dates. Okay. So let's check. Is there any null values? Now I want to remove. Is there any null values? I want to remove them. Handle null values. So since this is a large data set, I'm not considering about handling them. So if the data set is smaller, we can't remove. So what we do is we calculate the average and fill this data with average, right? So here I will remove the null values. So let's check, is there any null values? Data is null values any. Data dot is null dot values dot in. So it's giving me an output as np dot false, right? np dot false. But I want this output to get as true or false, right? If there is any null values, I want to get true. If there is any no null values, I want to get as false. So to do that, we are using a library as NumPy. NumPy. So I need to import that as well, right? NumPy is for stand for numerical Python. So it's a open source library in Python used for numerical and scientific compute. So this return type is, you can see, NumPy Boolean value. It's returning me a NumPy Boolean value. Data dot is null dot values. So it's returning me false, right? Using NumPy lib. Okay. So it will return me false. Okay. Okay. All right. So we have it false means there are no any null values. So I don't need to uh, uh, remove any null values, right? Okay. Now what I want to do is get insights about this data, analyze this data. So I will use to analyze, we need the data visualization, right? Data visualization. So I will do simple data analysis using Seaborn library. So for the data visualization, we use Seaborn library. See, what is Seaborn? Seaborn is a Python data visualization library. Seaborn is a Python data visualization library based on Matplotlib. Matplotlib. It provides a high-level interface for drawing attractive and informative statistical graphs. Right? So now I want to do a statistical analysis. So using a statistical graph, so I can use this Seaborn library. So I will install this library, install Seaborn. So I will import that library, import Seaborn, SNS, rail plot. We can X, for the x-axis I will get the confirmed, y-axis for the I will get this, right? So then I can draw a chart like this, confirm with dates. That's it. So this is data visualization, right? So we can, after analyzing the data, we can draw the draw a chart like this. So what this chart tells us? So whenever the after right, when the confirmed number of confirmed cases get increases, deaths get increases, right? That means over the time they have we can say they have increased the uh, increase the what do you say, PCR or the rapid test, the increase doing rapid PCR tests in their society. So when the like number of confirmed cases, the confirmed and the deaths has a so you can see over the time, so our death count has gets has get increased, right? In some, this is for there are multiple lines because there are some different regions. So you can see some regions has a lower death rate, and one region has a uh, compared to others has a this is the total deaths, and these are the deaths by the region, right? So you can see over the time the death rate got increased, and it's now coming to a like a the rate is the increasing rate gets drop, right, from this period to this period. This period, from this period to this period, there is a very much increase in the death count, right? So here 0, and in a very short period of time, there is a rapid growth in the death count, right? Right? Uh, and it's getting the rate of the rate is getting uh, decreased. Okay, so that's how we can do a data analysis using Jupyter Notebook. Okay, Budhi? Okay, Budhi? Right? Understood, right? So now I will move to one of the important points. So now let's move to our the next topic, regression analysis. Regression analysis. A regression analysis is a method for modeling relationships between variables. It's a method for modeling relationships between variables. So, which make it possible to infer or predict a variable based on one or more variables. Makes it possible to infer or predict a variable based on one or more other variables. In regression analysis is a method for modeling relationships between variables. So, as an example, what we can see what influence a person's salary. So, we have number of things. Let's say age, his education level, then his experience. We want to check whether these things influence a person's income. Are these things influence a person's income? So that's regression analysis, modeling relationships between variables. So the variable we want to infer or predict is called dependent variable. So this we call as the dependent variable. The variable we use to predict are called independent variable. These are called independent variable. So we are checking whether our independent variable influence the dependent variable. Is there a relationship between the independent variable and the dependent variable? So we use this in hypothesis testing as well. We use regression analysis to achieve two goals: to measure the influence of one or more variable on another variable, and to predict one variable by one or more other variables. As an example thing, what will influence a student's performance in exam, right? So we check, we try to determine some parameters. We will determine some parameters, and check whether are they influence on this are the influences performed. So here what we do is we are determining some parameters and checking whether are these influencing his performance. Like let's say his his concentration or his mental state. So we can find some parameters and we check whether are these influence his performance. Then in this case, we are trying to predict one variable by one or more other variables, right? So here, here we checking, we check, we are determining some parameters and check are these parameters influence the observed parameter. So the student performance are the student's mental health, is it affecting his performance? So that's what we do here, right? So this is mainly using research, right? This analysis, what we are doing is we have some parameters. So we know, okay, we understood that, let's say mental health is impacting the student's performance, right? Performance. Or for a better example, let's say a patient in the hospital, a patient staying in a hospital. So we check whether based on his preconditions, and his type of disease, we know these things will affect the number of days he will stay in the hospital. So based on this, we will predict the number of days he is staying in the hospital. So here we are checking whether some variables influence the other variable. So here we are checking based on these variables, how much we try to predict the outcome of one variable based on the other variables, right? Here we check in the influence, and here we check in the predict the outcome of one variable. Okay, these are the main two objectives of regression analysis. We have different type of regression analysis called simple linear, multiple linear, and logistic. So in simple linear, we have one variable. And let's say x. We try to predict his influence on another variable. So there is a simple linear. So the equation is y equals mx plus c. You can remember this in your mathematics, right? So in a simple linear relationship, we have this mathematical relationship by y equals mx plus c. Then in multiple linear regression, we have multiple independent variables x1, x2, x3, and we try to check the influence of one variable, right? Logistic regression analysis is used when you have a categorical variable. So to get a practical understanding of this concept, let's do another project, right? So let's create a new project. So type Jupyter Notebook, Jupyter Notebook. Create a new Python project. So I'll name it as company dataset. So I have a dataset about company data. So I will first import the libraries. Import libraries. I will import pandas, then NumPy and Seaborn. Right? Then import the dataset. Let's name it as companies equals pandas dot read CSV and the path for the particular CSV file. So this is my data set. I have 1000 companies. So I want to open this CSV file, right? Right. So let's see what's inside this CSV file. So I will open it as a data frame, right? So here I have the R&D spend, administration, marketing spend, state, profit. So what I need to do for this is do a regression analysis. To do a regression analysis, right? So I want to check the influence of these variables, R&D spend, administration, marketing spend, state on the profit, right? So my independent variables are R&D spend, administration, marketing spend, state, and what is the influence of these variables in profit. So let's so these are the this is my data set. So I will first extract the independent variables. So I'm saying x equals, so my independent variable, you can see it's the last column. So I want to get all the my dependent variable are all the columns except the last. So I say x equals companies dot ilog companies dot ilog all the companies, all the values sorry, all the values except the last column. All the values except the last column, -1 dot values. X is equal companies in the data set. I log all the columns except the last column. Okay. Then extract the dependent variable. So dependent variable is the 5th column. Okay. So y is equal companies dot I log the 5th means first column is 0, 1, 2, 3, 4. The 4th column, right? Comma 4 dot values. So what I want to check is what is the influence of x in the y. X is, here we have the multi-regression analysis, right? So x is all these things and y is the profit. Okay. So let's draw a basic plot, right? To check the influence. So we can draw a basic plot using, we drew a plot diagram. So to do that, I'm using a library as Matplotlib. Import Matplotlib dot file plot as plt. So, and I want to show the live diagrams in line. So I need to import this library as well, right? So now you know what is a library, right? So when you are doing a project, you have to use different libraries, right? So you can, with this understanding, you can do complex data analysis project, very complex data analysis project, and the machine learning project as well. So let's take A as for a, what do you mean by plot diagram is, let's take A is as 1, 2, 3, 4, an array as 1, 2, 3, 4, then B as 10, 20, 30, 40. Then we can draw a plot diagram using matplot. We have import matplot as plt dot plot A and B. So you can see, we can get the plot diagram. Compute the, we will show the correlation metrics. So for our data set, that SNS, I will draw a heat map, companies. So first I will calculate the strength and a relationship between numeric values, numeric variables, using what? We use correlation. We learn about statistics, correlation, right? In statistics, we learn about correlation. So in this library, we have an option as, when we are drawing the heat map, we have the option to calculate the correlation using this method. For this data set, I am calculating the correlation. Right? I'm getting an error. Heat map companies dot core only for the numeric values, because the error says cannot convert string to float nibute. So in our third column we had the string values as well, right? So non-numeric characters. So we only calculate the correlation for the numeric only. So if you want to calculate for the string values, we have to convert them into a numeric values. Then we get this heat map. So you can see the correlation. R&D spent has a 0.58 relationship with the administration. So what does that mean? So that means for let's say R&D spend has 0.95 relationship with profit. That means for additional unit of R&D spendings, the profit will get increased. Right? There is a strong relationship between R&D spend and profit. Right? And there is a less relationship with administration and the profit. So here this line has the 1. So that is meaningless because profit has 1 like strong relationship. It's 1. 1 means profit is profit. There is no relationship between profit and profit, right? So it's obvious 1, right? Then this middle line always it will be 1 because this is a multi-regression analysis, right? So R&D spend and for its own x value and the y value, it always will be 1, right? Then there is a very low relationship with marketing spend and administration, and R&D spend and administration, right? So that's what this diagram shows. So you can see we do a multi-regression analysis with a heat map. Okay, so this is how we can do a multi-regression analysis. Okay, so simple multi-regression analysis we can do like this. So these are the basic theories. So we can implement these theories. Actually, a real world data analysis project is much complex, much mathematical calculations and these things needed. So, so this is a very brief idea for you to get a simple idea about how we can do a real world data analytics project. Okay.
Sure,
If
sir.
you have any concerns, you can contact me. Okay.
Okay.
Okay. So thank you very much then.
Okay, sir.
Thank you.